Hello all, welcome to my channel. Today in this video I will continue from the part 1 or previous part regarding to modeling of the shear wall. In the previous video the modeling part has been finished. Today the application of load, defining the load cases and load series as well as cyclic pushover analysis will be conducted and compare the obtained pushover curve with the experiment curve. So let me turn into the perform 3D model, and I would like to say that this video will be useful for the student or the engineers who are learning perform 3D, or it's only for the academic purpose. So this is the shear wall. Here the properties of the shear wall has been already assigned. Here these are the confined concrete, and this middle portion are the unconfined concrete. So after the property definition, assigning of orientation, and let me turn into the load pattern. Here this is the load pattern type. Here the load patterns are 3 types. The first one is the nodal loads. The loads can be applied into the nodes like these nodes. The second one is the element load. This load is not here, but in case of the structure the element load is very important. And the last one is the self weight. So this is the overall self weight of this shear wall. So let me start from the nodal loads. Start new nodal loads. I give a name axial load. Here we know that the axial load ratio is 0.07. I have calculated the load ratio into Newton and kilonewton unit and divide that load into different 5 nodes at the top of the shear wall. So the edge nodes have same value, and these 2 nodes also have same value, and the central node has different or more value. So let me introduce this value into perform 3D. So here these 2 nodes have same gravity load, minus 21768 Newton. Minus sign is towards the downward direction. Okay, then this value, these nodes have value of 77202 Newton. Okay, and finally the central node has 110,867. Okay, then after the assignment of this nodal load I will go to the self weight. Let me define self weight, and click somewhere in the display menu and drag to select all the element of the structure or this shear wall and click OK to define the self weight. So after this video let me turn into the drift and deflection section. As we know that drift is the horizontal displacement of one node or the upper node, this node, with respect to the lower node. Here this one is the base of the structure and this one is the top of the shear wall. So the drift is the relative displacement of these 2 nodes divided by the height between the nodes, this shear wall height. So if the upper node is at one floor and the lower node is at bottom floor, the drift will be considered for that particular floor only. So let me define the drift. Go to new drift. Here we can define the drift as a simple drift, and this shear wall is aligned along the horizontal h1 direction. So let me choose the here is the indication of this shear wall or any structure. So this one is the lower node and this one is the upper node, and this is the height. So let me define the roof according to this notation. So first of all, let me go to upper node, this green line or green dot, and let me select the lower nodes. Okay, and let click paste. Okay, so the roof drift has been defined. After the definition of roof drift, let me turn into the structure sections. Here in the structure section there are three sections. The first one is define section, second one is the strength section, and third one is the group section. For this server we will go to define section only, because the structure section is the cut through all or part of the structure by which the behavior of the structure like drift, displacement, shear force, bending moment can be found on that cut section. So here I want to define a section at the base of the shear wall. So let me show how to define. I put here name the base, and there are two options to have the section. So the first one is the use midpoint of the section, and second one is the specify coordinate. For now I choose midpoint of the section. Otherwise, where you need the behavior or the sectional force, you can indicate that coordinate here and get that value of the force after the analysis. So here I choose midpoint. Then after that I select the nodes. Here there is an option of add or delete curves. So now I add curves. If you wish to delete, it can be done also. So here that section is defined at the base of the shear wall. So after that we have to go for limit state. So for the analysis to stop, we have to define the limit state for every nonlinear analysis in Perform 3D. That limit state can be controlled by deformation, strength, drift, deflection, or structure section. So for now I choose the limit state as a drift. So let me define the drift. I call it roof drift. So we have to set some reference limit to control the analysis. If we do not set this limit, Perform 3D has default component to set the limit. That default component is the X point on the trilinear backbone relationship while defining the material properties. That's the default. But now I limit the analysis by the drift value. So let me put 5% for now. Okay, it's for all drift, or you can choose highlighted drift. So I go for all drift. Okay, it's already saved. Then let me save the structure. From here, all the modeling phase as well as the application of the loads, defining the drift limit, defining the section cuts, limit state, everything is finished for the modeling phase. So now let me turn into the analysis phase. Here the first step of the analysis phase is to define the load cases or set up the load cases. So we are going to conduct a cyclic pushover analysis. So in pushover analysis, the gravity, first of all we have to define the gravity load just like in et.al, in nonlinear gravity load, and after that the end of the gravity load application, the pushover analysis can be conducted. So let me define the gravity load. Okay, this one is the gravity load definition case. So here we can select the nonlinear and control information for nonlinear analysis. So the number of load step is 50 because perform 3D user manual has guided how to put the values or what values to be input here. So I put here maximum value events in any step is 100. This one is the first step. Then I have to add the load pattern which we have just defined in the previous modeling phase. So the scale factor for the axial load is also 1, and there is no element load, there is a self-weight, scale factor is also 1. So here limit step to stop the analysis mean if we don't have any drift or deformation or any other limit state assignment, this is the default value I have already told. So now we have a drift definition and the limit state has been already defined for the drift roof drift. So let me choose this, then click save. Okay, after the load cases of gravity, then we have to go for the static pushover. Here the dynamic earthquake load also applied with this tab. This is the load application tab for dynamic load, but now we are going only for static pushover analysis. So for the static pushover analysis, the different load cases have been set up. Okay, these are the load cases developed for applying the pushover analysis, starting from plus 0.1% to 2.5% minus 2.5%. So let me define these load cases. At first we have to start from plus 0.1%. okay, then it's a displacement pattern. The structure is pushed on this mentioned value of drift, so we need to choose for the displacement pattern. The number of load step is 50, maximum number of event in any step is 100. This is the initial step to first step, and maximum allowable drift need to be defined. How much value the structure can be pushed, this is the limiting value to push the structure, and the direction can be defined below, and the limit is drift. Okay, then we have to specify the horizontal displacement pattern. The first point is the base of the structure, there is no any displacement, and the second point is the overall height of the story, or for our case the top level of the shear wall, which is 36 and 58 mm, 36-58 mm height, and the direction indication is here. So for now I push the structure for positive h1 direction, so that I put here +1 value. So let me click OK. Then after that I have to go for negative 0.1%. For that everything is same except here this allowable drift, and the direction is along the negative h1 direction. Similarly plus 0.25%, the drift is 0.0035, direction is +1, other thing is same, again minus 0.25, drift is limit is 0.005, direction is -1, negative means along the negative h1 direction. Then let me go for plus 0.5%, it's 0.0075, direction is +1, and for minus 0.5% is 0.01. It is -1. Again for plus 0.75%, value is 0.0125, direction is +1, and for minus 0.75, the value is 0.015, direction is along -h1. Similarly for +1%, the value is 0.0175, direction is +1. Similarly for -1, the value is 0.02, direction is along -h1. Similarly for +1.5%, the value is 0.025 is +1. Again for -1.5%, the value is 0.03, the direction is negative. Similarly +2%, the value is 0.035, direction is +1. Again for -2, value is 0.04, -h1 direction. Everything is same except only two values. +2.5%, +2.5 means 45, +1, then -2.5%, 0.05, -1. Okay, then finally we have to close the loop, so I put here +0%, the value is same, +1 positive direction. So this value is from returning from 2.5 to 0 position, 2.5% drift to 0 position, and this -0 means to complete the loop, returning to -2.5% drift from 0 position, in negative direction. Okay, so here the load case also have been assigned for the pushover analysis, cyclic pushover analysis. After that, here if we check the previously assigned values for gravity, this one is the gravity load case, and for pushover analysis, these are the load cases defined for pushover analysis. We can change or we can alter the value if we have some mistakes here. So after the load cases definition, let me turn into the run analysis series. So before that, the structure is checked, so let me click the check for the structure. It means the structure and loads have been checked, no errors are found, and you can continue. So let me start a new analysis series case. So I give some name, CYCLIC, cyclic push. So okay, then for the basic plus masses section, the basic parameter is a type of load sequence. If we put the standard value, the load sequence will not be increased, I will show later. So we need to put general, and we have the option to include p delta or no. So for now I will not consider the p delta. We can compare the analysis result with considering and without considering the p delta. So for now I will choose no, and the event overshoot factor is default equals to 1. So if we have to increase the analysis time for heavier structure, for multi-story buildings or structures, we can increase up to 5% according to Perform 3D user manual. So we have defined the mass properties in node section. So the number of model, let me put 3, and for nodal mass let me give the section scale as 1 in order to show the model properties of the structure. So for damping we can choose the model damping. So I put here 5% for all modes, and now I will not model the relic damping. So let me click OK. Yeah, this is some warning regarding to relic damping recommendation, so it will not hamper the result now. So here the another tab is open, which is set and run analysis. So before running the analysis, before we do analysis, we have to define the analysis list. So at first the gravity load have to be applied like this, then after that let me select the pushover load, and here the preceding analysis number is 1. If we select the standard value here, standard, that number cannot be increased, but now the number can be increased accordingly. So let me make a list of load cases. Add, another one is also add. Okay, I will continue up to the last. Okay, we have finished. After preparing the list for analysis, so we can click go to run the analysis. So let me click go. So it will take some time. Okay, the analysis have been finished. Let me click OK. From here the analysis has been completed or not, we can check from here. So if you look into the details, the analysis was run successfully, the full specified load, drift or the time was considered. You can process the result. If the analysis was stopped due to some error or due to some reason, here in this analysis detail dialog box, what is the problem or why the analysis has been stopped, it can clearly mention here. So everything is okay here. Then after the completion of this analysis, then we have to go for the result. For now I directly go to the time history section. In time history section we have node, element, drift, reflection and structure section. As we have defined the base as a strength section cut for structure section, the result will be produced on that section cut. Every results what we generate from the Perform 3D or analyze from Perform 3D, the result obtained is on the base of the shear wall. So I choose the structure section. Here at the base we have single section, and the application of load is multiple load, because these are the load we have applied on our structure for the case of pushover analysis. So I simply check the select all. It means all the values, all the load cases definition or series have been selected, and let me click plot. Okay, this is the cyclic pushover analysis curve obtained from the Perform 3D. So I will transfer this curve into Excel sheet and try to compare this curve with the experimental value, this experimental value. I will compare the obtained analysis cyclic pushover curve with this value. So let me transform into the Excel. Also here, if we unselect this box, then the pushover curve will be disappear. For example, if we select the initial load, the pushover curve, the starting point is like this. Here we have put for 0.1% drift, we have assigned the value, the control drift is 0.001. Yeah, this the curve is linear. The simply twisting of this curve is due to the initial crack of the shear wall. So if we push the structure towards the negative H1 direction, it follows the path or not, let me check. Okay, for negative H1 direction with the same value of the positive drift minus 0.001, at the first step the structure is pushed from 0 to 0.1% here, and for negative 0.1 the structure should be displaced with the magnitude of this 0.001 and another 0.001. mean we have assigned the value of 0.002 for unloading, and again the returning purpose. So the curve is written by following the same path and has gone to control to this value. Again, if we choose this 0.5%, it goes here with the same values of returning. It means the structure is still elastic. And if we click this same path, and if we go here, it's okay. Then for negative 0.5%, the structure unloading curve is not similar to the previous one. So like this, if we select all, the pushover curve is obtained in this form. So to save the value here, let me save the structure somewhere. I browse at desktop. In the form of text file, I put cyclic data. Okay, the text file has been saved in this location. I will process the text file and convert and transform this curve into Excel sheet, and will compare the curve with the experimental value. Yes, this is the cyclic data for the pushover curve. Let me select all the data. Let me open Microsoft Excel for now. Let me paste here, and these values are comma delimited value. So let me go to data tab, separate, and this value the delimited by the comma. Okay, then these are the values. The first one is the drift value, and the second one is the base shear value at the base of the structure. The force obtained by the cyclic pushover analysis, which is in Newton. We have defined the force in Newton. So let me plot the graph cyclic pushover curve here. So here, this is the cyclic pushover curve obtained from the analysis. The lateral force obtained on the cyclic push is in the y direction, and the displacement or the drift percentage is in the x direction. So let me compare this pushover curve with the experimental value. Okay, this is the cyclic pushover curve obtained from the analysis, and the unit has been converted into kibs from kilonewton because the experimental value I have presented is in kibs unit. So let me compare the experimental value and the analysis value. Okay, this is the comparison of the experimental value and the analysis value, and from the analysis the result seems reasonable. Only some unloading stiffness is higher in analysis value, and some reloading stiffness is little bit higher. So it looks promising with the calibration factor mentioned in the analysis for YULRX for the concrete material as 1, 0.4, 0.4, 0.1 and 0.1, and for the reinforcement steel all the cyclic degradation energy degradation factors are 0.75. so it looks promising, and the analysis is quite interesting, and I am also happy to obtain this curve. So the analysis and comparison of cyclic pushover curve with the experimental value in Shear. Thank you for watching. Thank you so much. Keep watching my videos, and don't forget to like, comment, share and subscribe my channel for more useful and informative videos. Bye bye.